If b is any positive real number with b not equal to 1 and x is any real number, b to the negative x is defined as follows. B to the negative x equals 1 over b to the x. Use this definition and the definition of logarithm to prove that log base b of 1 over u equals negative log base b of u for all positive real numbers u and b with b not equal to 1. Now, one thing we're not allowed to do is we're not allowed to take this and fiddle around with this equation. We're not allowed to do stuff to this equation because this is what we're trying to prove. You're not allowed to assume the thing that you're trying to conclude in order to conclude the thing that you're assuming. That's not allowed. And so to prove this equality, what we're going to do is we're just going to start with the left-hand side here, log base b of 1 over u. Now, based on this definition, b to the negative x is defined as follows. B to the negative x is 1 over b to the x. In the same way, we can write this 1 over u to the 1th power as u to the negative 1. That's using this definition here. Now, I want to be able to convert this into an exponential equation, but right now we don't really have an equation. We've just taken the left-hand side and done stuff to it. So what I'm going to do is I'm going to set this equal to just something like a capital K, and we'll work with that K in a second here. But what I'm going to do is I'm going to rewrite this equation here in exponential form so that b to the k equals u to the minus 1. Now, what we can do here is we can essentially reciprocate both sides. But put a different way, we can take both sides of this equation and raise it to the negative 1th power to get b to the negative k equals u to the 1th power, which is just u. And now we can reconvert this back into logarithmic form to show that log base b of u equals negative k. And from here, we can solve for k by moving the negative to the other side to get negative log base b of u equals capital K. So both of these things equal capital K, whatever it is, which means that they both have to be equal to each other by the transitive property. If this thing equals k and k equals this thing, then these two must be equal. Thanks, everyone, and I'll see you in the next video.